Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey everybody, and welcome back to the Digital Enterprise Society podcast. Thank you so much for picking this podcast. There's like 2.5 million podcasts out on the internet, and we are so glad that you're here with us today because this is the show that was designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, go to digitalenterprisesociety.org. My name is Thom Singer, and I get to co-host this show every single week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, here we are again.
Hey, Thom, it's good to hear your voice. And yes, here we are again. And I'm looking forward to another battle. This will be an interesting discussion. It's very passionate. There's lots of people that have various views on this topic. And so we'll see if Mark and I can shed some more light on it.
Awesome. Well, those of you tuning in who are regular listeners, you know that every few weeks we have the Digital Enterprise Society Digital Battle here on the podcast. And that is where Craig Brown, my co-host, goes head to head with Mark Pendergast. And Mark has decades of PLM experience, and he serves as the trustee for content for the Digital Enterprise Society. And Craig and Mark, they have a lot of opinions. And so what we do here in the battle is we bring up a topic and they get to battle it out, which is always a lot of fun. And today we're going to talk about 2D drawings versus only having 3D drawings. Now, if you think about it, for thousands and thousands of years, people who did design had to design it on paper. And that was the way it was. But now we've moved into this digital age and we can do 3D modeling. Why in the world do people still persist that they want it on paper? Well, that's what we're going to talk about today. So is it 2D drawing still necessary or 3D only? So Craig, let's start with you. What do you think?
Well, 2D was just the way we communicated, right? We wrote documents, we wrote pictures. And then when we got better and better at precision manufacturing, we put key measurements on the drawing. And the drawing was used by a skilled craftsman in a factory to get a key measurement, right? So make the diameter of this shaft exactly 1 inch, right? And so they had calipers, and the calipers you put on the drawing, and the drawing showed you set the caliper this way and then use the caliper to see if the shaft is exactly the right size. This is important if it's a rotating surface that has to fit in a hole, right, of the slightly bigger size, right? So the evolution of why 2D drawings had a lot to do with what the guy on the floor needed in order to make the part, right? Or to make the car. It's also the way humans communicated. I mean, even in most printed materials since the time of Gutenberg, it's not 3 dimensions, it's 2 dimensions, right? You express yourself in drawings and pictures. That's why it's called a 2D drawing. It's just 2-dimensional, right? But everything we do in engineering is in 3 dimensions. And in fact, if you think about the passage of time, it's in 4 dimensions. And so it's to technologists like Mark and I in our career, you would think people would naturally embrace a 3-dimensional model. The trouble is it's got more views. It's got infinitely number of more views. And that's part of the confusion that people have if you're using a 3D model to make a part. Well, if you got a 3D model and you got a robot making the part, I'm not sure you actually need a 2D drawing anymore, except you got lots of people that's what they're comfortable signing off on. That's what their contract is, if you will, is a piece of paper that you can put a signature on. And so there's lots of reasons we still have 2D drawings, and there's lots of good reasons we could start getting rid of them. But it takes a willingness of the people that use 2D drawings to run their business to change. And like all change, some will and some won't, and that's where we're at. But 3D models are a lot richer. If you put them in motion in 4Ds, they're even more important. And you got to figure out, well, how do you communicate to that person making the part? The more parts are made by machines, meaning robots and so on, especially mass production parts, well, then the more this all is an academic exercise, and it really doesn't matter because those guys need the 3D model. They use the 3D model. So, well, maybe that will be the end of 2D models or 2D drawings is when only machines are making parts. Sorry, craftsmen.
So Mark, what's your take on this?
I think we're going to live in the 2D world forever. I really don't see it going away, and there's a lot of reasons for that, and Craig touched on some of them. In fact, I don't know. I think Craig did the whole podcast in summary there, just in his little speech. So, no, I think part of the reason that we're going to need them is for, as he said, commercial reasons, legal reasons. Our legal system is still stuck in probably the 19th century. You know, a lot of our manufacturing is just coming out into the early 20th century. And they want the specificity of a drawing, that concreteness. And I think a very interesting point that Craig brought up is the 3D model doesn't draw your focus anywhere. It doesn't tell you what's significant and what's not. Whereas a set of drawings very specifically says, this is the dimension that's critical. This is the cross-section that you should be looking at. Here's what I really want here. Here's the notes that tell you exactly how I want you to put this thing together. And that clarity, that specificity of exactly what's important is really part of what drives the value of those drawings. And I think they are needed because the designer looks at that 3D model and all that is already in his head. The significant parts, what's important, what's not. When you hand that off to someone who's unfamiliar with it, they're navigating from zero and they have to look at these infinite views, 360, and say, I wonder what's the important parts of this. And drawings serve that purpose. Also, in a 3D world, where do you put that note that says, oh, by the way, make sure you don't break this tip off, or make sure you sand this correctly, or make sure that this is plated with something. It's not obvious how those things get incorporated into 3D, yet it's just very natural for us to include those in the 2D representation because that's how we communicate a lot of information. So we know how to do it, and everybody's conversant in it.
So that leads me to the next question I was thinking about, and you sort of touched on it, Mark. What are the challenges that are inhibiting us from eliminating paper drawings? I mean, you sort of touched on that, but there's got to be others. What are some of the things that are keeping us from going there?
Okay. Well, I think one of the big ones is manufacturing. And a lot of manufacturers are little mom and pop shops, and they don't have access to a lot of technology, but they're very, very good at molding parts or cutting metal or doing the things we need to get us the parts we want. And they're very agile and very efficient and very low cost because they watch their costs like hawks. And they don't have the resources to go out. And in some cases, they don't have the resources to even go buy the 3D software to look at the model. And if they want to do business with 100 big OEMs, then they'd have to go buy 100 pieces of software and learn how to use them. Whereas if you send them a drawing set, that is no expense. It's a PDF or it's a piece of paper. And they go, yeah, I know exactly how to read these. And I don't need any special tools that would increase my burden structure to do them. And in many cases, they don't have the big automated robots. They got a guy who's real good at spitting out metal chips or running a molding machine, and they're very good at it. And those low-cost suppliers, our purchasing guys say, hey, your materials cost too much. I want to use them, and they can't afford to run off the 3D.
So, Craig, what's your thought? What's inhibiting the elimination of drawings?
Well, I absolutely agree with Mark that it's that kind of a manufacturing site. And what I have said to more than once to the solution providers, the people that build the tools that build 3D models, come on, everybody. It's really easy to auto-generate the 2D model drawing that those small manufacturers need. So get on with it, right? And they don't see it that way, but it's okay. I'm entitled to my opinion. I do think asking the small shops to embrace 3D models is going about it the wrong way. And so this has been one of the huge roadblocks is we want that cost benefit, that low cost ability to make this particular kind of part over and over and over really well. But then we say, why aren't you 3D models? Well, because it's like talking in a foreign language, right? It's like using French as the diplomacy language when in fact all we really know is American English, right? So that's part of the problem. Well, building computer-based programs that can build the view for them is absolutely possible. It's not hard technology, just get on with it. And then auto place the notes. I mean, we ran a couple plays in the last decade of my career where we did exactly this. We stopped manually creating the drawing. So that's one step, right? How does the 2D drawing get created? Well, anybody who's my age, that's what you did in college. You did it with paper and pencil on a drafting board. And you know, the digital computer side was another decade coming. And so you know what it means to do that. And you think through these things Mark mentioned about, well, how am I going to manufacture it? What surface finish really matters? So you knew where to put the note. It was kind of obvious. Well, I think best practices are known and they could be put into these auto-generated 2D drawings. So step one would be auto-generate it. And then step two is to those mom and pops who want to learn how to use 3D models and maybe see other benefits, make it free. And I'm not kidding. Make it free. They should have the ability to not have to spend tens of thousands of dollars to go off and get a license in order just to look at a model. And so that's going to take solution vendors and big OEMs to duke it out and figure out how to do that. And I think we've seen some innovators. We've talked to a couple of them in this podcast series where visualization becoming very inexpensive, cloud-based and all the rest of that. That might be part of the answer. And then again, there'll be a button on the visualization. When you get a view on your computer screen you really like, you say, make 2D drawing. So you can ship it to your floor and people can have what they need down there. There is a company, so this took a company to do it. There's an aircraft company, it's probably a decade old now, where they just committed. They just said, everybody, we're going 3D model, here we go, we'll work through the details. And they were surprised, it only took 3 or 4 years after they started, that the guys on the floor, the guys that used to insist on 2D drawings, the guys on the floor said, this is much better. Why is it better? Guess what? Every 2D drawing is kind of disconnected from every other 2D drawing. And so part of their quality problems came from misaligned 2D drawings. Well, how do you fix that? Well, you do these intrinsic, thorough, costly reviews of looking at two drawings and making sure they're consistent, right? And sure enough, humans are fallible. We sometimes mess up one of the drawings and we miss it in the reviews. So one benefit of 3D models is you just eliminate all that, right? You auto-generate the views and they're coming from the same, if you will, source code. And that's what makes them much more reliable. So there's other failures of 2D drawings, the way we use them. And I think people might benefit by looking at those failures and then asking yourself the question, well, if I just use a 3D model, well, I've avoided that. And there are many like that. Any complicated mechanism that has friction and forces probably is better off in a 3D model. Just so you understand failure modes. So discovering failures is another reason for a 3D model that maybe moves, though it's in 4D. You'll never get that from a 2D drawing. It'll only be the human looking at a 2D drawing that'll be able to make the mental leap of what might be going wrong. So yeah, there are hurdles, but like every new adventure or every new way of doing work, those that try it and figure out how to do it, they'll be the leaders for a while. And that's how innovation happens.
So, but then you run into the problem of proprietary data structures.
Well, yeah.
I mean, this is great that you're saying, at least with paper, the paper I have, when I hand it to you, you can read my paper. What happens in the world of proprietary data structures where one system won't talk to the other system? How do you deal with that?
Oh, yeah. Standards. I mean, we've always dealt with that in the history of engineering with standards, right? And some people Boeing's been the one I've been most intrigued with recently. They are making a really big push that these interchange standards are important. So, I thought you were going to go down product proprietary too, which is a different discussion. I'll come back to it. But I think the way you fix exchanges between vendors is an industry standard, an ISO standard that says this is how we exchange it. There are some, but the OEMs and even the big tier ones have to insist that the solution vendors support them, right? And don't think the solution vendors will do this out of their own good-natured goodwill, right? They don't really have an incentive to do that, right? Because they're opening the door to a competitor. Whereas the OEMs could demand it, like what Boeing is starting to do. So I think that's really good, and I think there needs to be more of that. That's how you fix proprietary software. Mark, what's your view? And then we'll come back to proprietary products for a second.
Okay. Well, I think, again, if you're big enough, you just put down a hammer and you say, thou shalt.
Yeah.
And you don't care that you're paying a premium because you're inefficient as heck anyway. So you just shut out the mom and pops. You just tell everybody they got to use your stuff, and you deal with it. But I think it really inhibits the flow of information. As you said, the vendors are incented to not allow data to flow smoothly. In fact, what they do is they take your wonderful standard and they start putting options in it. And then all of a sudden, the options aren't compatible between tools. Okay. We had a group that did nothing but transfer data to OEMs. And they spent forever. What do they call it? Flavoring, coloring. I mean, they sent this step model, and then they spent like a week trying to figure out, okay, the Ford one's like this, but the GM one's like this, and all these different options of how they wanted it and where they wanted it and what they were doing. And it was hugely expensive to send the 3D data because there was no standard. So you're going from proprietary to proprietary, but you're using some kind of neutral standard that the vendors have watered down to the point where, it's so flexible that it's not standard anymore. And I think that allows them to lock in, because you got to get it exactly their way or it doesn't import into their tool. And I don't know how you get around that, because the vendors do not want you to be able to export their data and move to their competitor.
Yeah, and when you say vendor, you're not talking about the builder of the product. You're talking about the builder of the software.
Yeah,
the software tool, and
the guy with the proprietary data structure. The ANSI standards, American National, whatever, and then the ISO standards. I mean, standards exist to encourage the exchange of information, right? Be it design information or other things. And I'm not a big fan of corporate, or of government regulations here. But that is sometimes why regulations come about, right? If a standard doesn't emerge that everybody embraces, well, then for the good of the countries, maybe you should do that. And so what we OEMs and we big tier ones need to do is put money behind that, right? So if a standard comes about, we need to make sure that it's profitable to everybody, that following the standard is better than not following the standard. And then the solution vendors, the tool vendors, they'll have to follow. So.
Cool. You said you wanted to go back to one other thing, Craig.
Well, another benefit, I'm the 3D model guy, but here we go. Another benefit of 2D is hiding proprietary information. So you only show what's necessary for the vendor to know, the company you're hiring to do the part. Especially in digital componentry, I give you the outline drawing to fit it into the harness. I don't tell you what's on the inside. Whereas and of course you can depopulate a 3D model, and I get all that. But the point is, 3D models show much more information. And if it's not something like a bolt that you can buy at a hardware store, but it's really proprietary, I'm thinking about these new, where people are doing printing of parts, right? Well, there's probably stuff in there that's proprietary. Even the shape of it is through some topology optimization thingy, right? Well, then I'm not sure you want to share it. And so there's another interesting challenge coming with 3D models, which is, well, what is it you want to keep proprietary? In the car business, we are all crazy about the shape and the look and the color. We camouflage everything, right? And so you could imagine 3D models getting the equivalent of camouflaging to confuse the user of the model. Well, time out. 2D models help this because the 2D drawing will hide these details from you, right? It's a cross-section of the fender. It has a certain shape. It doesn't show you the shape of the fender. It shows you the shape of one view, one slice, right? And so you can do that and hide information.
So, Craig, did you switch sides?
Yeah, if you want to hide it, 2D is better. That's the point.
So, Mark, any thought on that?
Yeah, well, again, it's one of those things where on a drawing, you have a lot of control. I know that same group that I talked about that was flavoring all those models, they also took all the smarts out of the parts. So we had parts where all the parts were related to each other with mathematical expressions. And if you move this thing, then something else moved. Well, if you give that to someone else, you want to take all that out because that's your secret sauce. And so they'd spend a week dumbing down the model so that we could give it to somebody and they wouldn't know all of our secret manufacturing techniques. So it is, again, you communicate very specifically what you think is important and what they need to know. Whereas in the 3D model, you're kind of giving them everything, and it's not always what you want to do.
All right, so we're not going to get rid of paper anytime soon. What's the right balance right now? What do you think that right balance is? Craig, let's start with you.
I think you're going to need both. I think you should automate the creation of the one from the gold source, from the source code that I talked about. So if you got a 3D model, generate the 2D model. And this last point we were making about keeping it secret, well, yeah, if you've got stuff in there that's the secret sauce, be it relationship equations like Mark talked about, then you just got to, generate that from the source code so that you're not regenerating it. Anytime you do a second manual operation, you run the risk of creating a disconnect, and disconnects cause quality problems, right? So I think 3D should be the king, and I think you should generate 2D when you need it for these various reasons I summarized. And I don't think you're going to get rid of 2D. I just don't.
Mark, you get the last word. What do you think is the right balance?
I think the right balance is 2D is king, and 3D is around because it makes it easier to create the 2D. But I do agree, 2D, for whatever reason, I find mechanical people especially see their drawings as artwork, see them as crafted things, and they put a lot of time into them and get the details just right and everything, and nobody cares out on the floor. I grew up out on the floor. I didn't care. Give me the drawing, give me the accurate measurements, I'm done. And these guys would just spend a tremendous amount of time making it literally a work of art. So yeah, this automated drawing where you say, hey, I want a section here. I want this. I want to throw these on these pages. I need some notes. I need this. And then have a compiler that just puts it together, I think is the right solution. In fact, in my history, one of our projects was we did this in a limited domain. So we did this for circuit boards, because circuit boards are very standard in how they go together, and they're kind of 2.5D-ish, so they're already ready to go. And we literally wrote a program that looked at the 3D 2.5D circuit board design and created the full drawing set, untouched by human hands, and it was amazing. And I'd love to see a similar one for mechanical drawings. Trouble is they have more degrees of freedom, but I could imagine you saying section here, cut this, show this, don't show that, blah, 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 and have a compiler at the end that just spits out a 2D set of drawings. That's where I'd like to go.
Awesome. Well, this completes another digital battle. Thank you, Mark, and thank you, Craig, for sharing your opinions. And thank you to everybody who tuned in and listened. Every single week, Craig and I try to bring to this podcast interesting interviews and exciting conversations that are going to help every listener enhance and grow their career. So join us every single week for more thoughts, ideas, and actionable information in and around product lifecycle management. Hey, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out, digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.